Within calculus, we've learned a number of ways to solve derivatives, and actually we have one more way that we're going to use. It's called the chain rule, and the chain rule is used to find the derivatives of composite functions. So if f and g are both differentiable, then the composite function f of x is equal to f of g of x, which is equal to f of g of x, is differentiable, and f prime of x is equal to f prime of g of x times g prime of x. So let's look here. If we wanted to calculate this, I just want to show you how simple the chain rule is and why it's kind of essential. If we have f of x is equal to 5x plus 3 quantity squared, if we want to solve it with the chain rule and without the chain rule, well, if I'm going to solve it with the chain rule, first I need to expand this. So I'm going to have, I always kind of like to write a little mini one next to it. So I'm going to have 25x squared plus 15 is plus 30x plus 9. And then I can actually find my derivative. So this is going to be 50x plus 30. Okay? But if I want to use this with the chain rule, I'm just going to start f prime of x is equal to, you're actually going to derive very similarly to how you have before. I'm going to pull this 2 in front, so I'm going to have 2 times, what's inside the parentheses? 5x plus 3 to the n minus 1 power, so that's just going to be the first power, times the derivative of what's inside is times 5. So now I have 2 times 5 is 10 times 5x plus 3, which is just equal to 50x plus 30. I got the exact same answer. But this second method is a little simpler, and actually I made it even harder by kind of going slowly. So as you'll see, this will become more and more simple as time goes on. So let's go through some examples here. The rest of this lesson, I'm just going to be doing a lot of examples. So here we have f of x is equal to the square root of x squared minus 1 quantity cubed. I'm going to actually rewrite this as x squared minus 1 to the 3/2 power. That's going to make life a lot easier for us. So then I'm going to find my derivative. F prime of x is equal to, I pull this exponent out front, so I've got 3/2 times x squared minus 1, I have to subtract 1 here, so 3/2 minus 1 is to the 1/2 power, and then I need to take this times the derivative of what's inside, which is 2x. So now I'm going to simplify a little bit. These 2's are going to cancel, so my derivative is just going to be 3 times, 3x, don't forget my x there, 3x times the square root of x squared minus 1. Much more simple than actually expanding this out and then taking the square root of everything. That would take quite a long time. So let's do another example. F of x is equal to -7 over 2x minus 3 quantity squared. I'm going to rewrite this. So I have -7 times 2x minus 3 to the -2 power. So f prime of x is going to be equal to -2 times -7 is a positive 14 times 2x minus 3, -2 minus 1 is -3, times the derivative of what's inside is just 2. So my final answer is going to be 2 times 14 is 28 over 2x minus 3 quantity cubed. And I wouldn't expand that. I wouldn't waste my time with that. All right, let's do about 4 more examples, and hopefully you'll kind of get the hang of this. So now we have y equals e to the 3x squared power. Okay, this one is not too bad. It looks really complicated, but I think it'll go pretty well. So y prime is equal to, we know that the derivative of e is just the exact same thing. So it's going to be e to the 3x squared power. But we also need to take this times the derivative of the exponent. So times the derivative of the exponent is going to be just 6x. So our final derivative is 6x e to the 3x squared power. All right, let's do a little bit of trig, make our lives interesting here. We have y is equal to the cosine cubed of e to the 5 theta power. I always like to rewrite these as cosine of e to the 5 theta power quantity cubed. That just helps me to kind of visualize and see where these things are going. So y prime is going to be equal to, first I'm going to pull out that 3. So I'm going to have 3 times cosine of e to the 5 theta quantity squared. So I've taken the derivative of, just like with the powers, like we've done before. Then I need to take the derivative of what's inside. So then the derivative of cosine is negative sine of e to the 5 theta power, right? I should have used the same brackets there, but anyway. Times, I need to take the derivative of what's here. Well, the derivative of e to the 5 theta power is just e to the 5 theta power times the derivative of that exponent, right? The derivative of that exponent is 5. And I really expanded that one out quite a lot, but hopefully it kind of makes sense to you here. So I've got 3 times a negative times 5 is a negative 15. I guess how do I want to write this? Sine of e to the 5 theta. Oh, no, I don't want to write that. Yep. Okay, I'm negative 15. I like to put, so I've got this taken care of. And then I'm going to put my e to the 5 theta. Good. And then how about sine of e to the 5 theta cosine of e to the 5 theta. And of course, it doesn't really matter. Cosine squared. Cosine squared? Cosine squared. Ooh, almost missed that. It doesn't really matter what order you write these in, but I guess as mathematicians, we like to make things look as neat as possible. All right, here we have the natural log of x squared plus x plus 1 quantity squared. Well, I can rewrite that. It looks like I didn't even write that this is f of x, but this is equal to 2, I'm going to use my exponent rules for logarithms, 2 times the natural log of x squared plus x plus 1, right? So the natural log, the derivative of a natural log, I'll call this, I'm just going to call it y prime, since I didn't label this, is equal to 1 over, we're going to have actually 2 times 1 over x squared plus x plus 1 times the derivative of what's inside here is 2x plus 1. And I can kind of put all that together. So my final answer is just 2 times 2x plus 1 over x squared plus x plus 1. Beautiful. And finally, let's just do one more. We have the tangent. We haven't done a lot with tangent, but it's always good to keep practicing our trigonomic functions. The tangent of the square root of 2x minus 3. And I might rewrite that as the tangent of 2x minus 3 to the 1/2. I mean, that might help you, that might not, I don't know. Well, the derivative of tangent is secant squared, so we have secant squared of 2x minus 3 to the 1/2 times, we have to take the derivative of this now. We have to take the derivative of the 2x minus 3 to the 1/2. So that's going to be 1/2 times 2x minus 3 to the negative 1/2, we subtracted 1, times the derivative of all the way what's inside there is just 2. All right, so now I have, if I simplify things here, it looks like I've got 2 and 2 are going to cancel out. So I have secant squared of the square root of 2x minus 3 over the square root of 2x minus 3. And that is our derivative. Okay, so hopefully all of that made sense. If it did not, leave a comment in the video. We'll work on this in class tomorrow, and I hope that you enjoyed it. Enjoy. See you soon. Bye.